A significant challenge for deploying machine learning-based systems is that their behavior can be very complicated, and validation of the exact behavior may be infeasible. A classic approach to dealing with this is to use the concept of a safety envelope. In this picture, we've represented the safe part of the state space of the behavior of the system with green, and the unsafe part that lies outside the safe boundaries with red, with this representing a multidimensional space rather than just 2 dimensions shown for illustration. If you want to validate or build a checking system that polices this boundary, that checking will be very complicated as the boundary gets complicated. The idea of a safety envelope is to first police the boundary, but second, come up with a practical way of simplifying the boundary so that the architectural component policing the boundary can be simpler than the thing attempting optimized behavior. To do this, a typical safety envelope simplifies the specification of what is safe, here notionally represented as going from a very complicated boundary to a circle. In practice, it may not literally be a circle, but the idea is that there's some simple-to-check boundary that is of low complexity compared to the actual boundary. This simplified safety envelope is intended to provide a simple, highly reliable way to see whether the system is safe or unsafe. A monitor is created to check whether or not the system is currently within the known safe boundary, the green, and when the boundary has been crossed, implement a safety shutdown to make sure the system remains safe. There's an inherent tension here in that the simpler the safety envelope is made, the easier it is to build a checker, but the more complicated behavior can be ruled out, even though in theory it would be unsafe, but the checker is not complicated enough to appreciate that. In practice, this pattern can still be useful because many times the complexity of the system operating in the safe space is not oriented toward safety, but rather toward optimizing other parameters such as fuel economy, ride comfort, and things of this nature. So while the use of a safety envelope reduces the permissiveness, in other words, the ability of the underlying control system to exercise the complete area of the safe state space, it does make it much more feasible and much more simpler to ensure safety is maintained, even if the system cannot be proven to be safe for all conditions.